So I'm talking about language as a cognitive toolkit. Hang on a sec here. And let's start with the great question that Gary asked at the beginning. Should we think about language and cognition as word to word, where we simply learn nouns and names of objects and verbs and names of actions, etc.? Or does language impose its categories on us? And I think Barbara also dealt with that a lot. Okay, so so I'm going to say the answer is actually both, and that they apply in different measure to different parts of the lexicon. And this, what you see on this slide, is a very old distinction between open class and closed class, where closed class words were function words, function and morphemes like auxiliary verbs and so on. Okay, I see a bunch of chats. Does that mean there's a problem?
No problem.
Okay, good. Just want to be sure the chats weren't saying we can't hear you or something. Okay, good. And then open class were all content words, so nouns, verbs, adjectives, whatever. I would suggest that that's actually way too simple-minded, and that the right way to think about this is as a continuum between words that are given to us pretty much solely linguistically, of which function words are the prime example, and words that are given to us very, very heavily by the world, where you can think of them as referential, and things like cow sort of operate that way. Once your 2-year-old has seen a cow, they're going to do pretty well at picking out other cows. So you can get a really good start on the meaning of cow, or at least some parts of the meaning, from reference to the world, whereas you can get absolutely nothing from reference for a word like of. And my suggestion is that prepositions are a lot like function words. They're very hard to get just from the world. And verbs are somewhere in between. And relational nouns like barrier and carnivore are also somewhat harder and more difficult to get from just looking at the world than sort of entity nouns like cow and spoon, and proper nouns like Fido. So if we take all that, first prediction is that in terms of acquisition, we should see the left end of the continuum coming in earlier than the right end of the continuum. And kids may say function words, but they may not use them in an adult-like way. They may use up only for being picked up, for example, at a very early age. So if we look at, this is a slide I stole from Trueswell and Gleitman, and we could look at Elika's work as well, but here's the input from adults in 2 languages for a sample population. And as you see, there are more nouns than verbs, but there's quite a few verbs. Here's what the kids do in their first 100 words. Pretty much ignore the verbs and learn the nouns. So I would suggest that these words are hard. Verbs are harder to get than nouns, and part of the reason is verbs, there are a lot of reasons, of course. Verbs are transient and so on, but also verbs involve relational meaning. Give involves transferring an object to an animate being and so on. So the mapping from word to world is more perceptually constrained for concrete nouns, especially entity nouns, than for verbs and prepositions. So that also predicts that relational terms should differ more across languages, because languages have to sort of choose from the world what partitions to make among the sort of relations in the world. And sure enough, I just remind you of the lovely slide that Barbara showed yesterday. This is Melissa Bowerman's work. Even among very similar languages like Dutch, English, and Spanish, you get different partitions of 2 very simple spatial relations, containment and support. And there's been a lot of really cool work on cross-linguistic variability, and a lot of it involves relational terms, verbs, spatial relations, and so on. And in fact, in this beautiful study by Asif Majid and their colleagues, where they compared 4 semantic domains, and they looked at how much Germanic languages differed in their way they lexicalize spatial relations, containers, and so on. And what they find is the most variable are spatial relations. Those vary the most across these Germanic languages. Body parts and colors vary the least. Now they all vary, but the amount of variation is greater for the relational terms. So here we take a big leap. Given that relational terms, so let me try to do this carefully. Relational terms pick out non-obvious connections in the world. And we know that they're at least not inevitable because different languages do them differently. So given that, there is the potential for relational language to teach us something that goes beyond what we could learn just from the world. So hypothesis, relational language can amplify relational cognition. I'm going to look at a really simple case. Oh, here are two particular claims, common labels and by comparison. This promotes abstraction. And since, for example, hearing the two things are both carnivores, might lead a child to compare a lion and a hawk, which they normally wouldn't do. They might see a commonality. Second one, linguistic structure invites conceptual structure, and that's the one I'm going to look at. We're going to look at same different relations with some students who've worked on them. And here's the classic task invented by Premack. It's called the relational match to sample task. If you look at this task and I say which of the bottom ones is like the top one, I think you'll all pick the two circles because you all think, well, that's the same relation, and the top one also shows the same relation. And you probably think it's really easy. It turns out it's not. While matched sample is very easy, and pigeons and apes and monkeys can pass that, relational matched sample is really hard, and most species fail it, sometimes after tens of thousands of trials. So one animal who could pass was Sarah, the chimp that Premack taught symbols to, and he believed that the reason she could pass was, notice that she has symbols for same, for same and different. He believed that she could recode the relational matched sample and think of it as same and different, and that this recoding gave her extra cognitive power. And of course, he thought the same was true for human language. So it has also been done with 4 new chimps who had only learned same and different symbols compared to 1 chimp who had not. And sure enough, the 4 chimps could pass, the other chimp didn't. These are small numbers, but that's because, fortunately, there aren't that many chimps being run in labs. So we looked at this with kids, 2, 3, and 4-year-olds. We give them 8 trials, no practice, no feedback. And basically what you see is they fail at 2, they fail at 3, and they pass at 4.5. So it's not duck soup, even for bright little humans. Now we ask, what if we did the same thing that Premack did for chimps? What if we teach them same and different before they do this task? So we made kids do a task where they get pairs completely different from the pairs they're going to see in the relational match to sample task. And they get feedback on every trial. They just have to say, is it same or is it different? After 21 trials, we give up, or we stop when they get 3 in a row correct. Then they go right on to the same RMTS task, 8 trials, no labels. And what you find is 3-year-olds succeed in the sorting, and they go on to pass the relational match to sample task. 2.5-year-olds fail both. And that's very frustrating to me. We've tried to get the 2.5s to do it. So far, we haven't succeeded. I'll just mention that in this first study, we only looked at same. So the target was always, the standard was always same. We thought that would be easier. Recently, we've extended that to mixed trials, 4 same, 4 different, or even all different. 4.5-year-olds pass all of them. Furthermore, so far, we taught them or primed them, however you want to put it, with same different right before the task. So the alert reader is probably thinking, well, sure, you prime them and maybe they're going to do it. But here's a little more evidence that suggests it's not just that. When we looked at the kids who succeeded in this task, particularly in the mixed task, and we asked them on the last 2 trials, what did you pick and why did you pick it? The ones who say something about same or different perform better than the ones who did not. That's the striped lines. The ones who spontaneously use the word same or different to describe their choice. And a similar result has been found by Holkman and Carey and their colleagues. They've also been looking at the relational match to sample, and they too find their kids pass later. I could tell you why, I have my suspicions, but same pattern. The ones who use same or different to describe why they made their choice do better than the ones who don't, and in fact are the only ones who pass. So same different matters, same different language matters for RTMS success. And practice with labels help. Spontaneously using the labels is a good sign that you're going to pass. And 5, and that's true for chimpanzees as well as kids. So I suggest that the conclusion is linguistic structure can invite conceptual structure. And that's it.
Thanks, Dedre. I think you've been the only one so far who's stuck to the 10-minute
Oh, God,
time.
I can't believe it. I had 37 slides this morning.
You were
I'm
at
very
exactly
pleased.
10.
I have a question, but also a quick comment, which is there's a paper, and I don't know if it's been replicated, but chicks with like very, very young chicks can do same different relationally when you do imprinting. They can do same shape, they can do same color. So I wonder how.
That's fascinating, and it's also been found for ducklings. I don't know the chick stuff yet. I've looked.
Maybe it was ducklings, and I forget.
Yeah, okay. You've seen one fowl. Anyway, it was ducklings in the one that I know of. And that's a fascinating study, and it very likely is something that I should worry about. But there are some ways in which there could have been some object similarities. So I'm looking at the stimuli in detail. I would love to dig into it a little more. But yes, that's a serious issue. By the way, Sue Hespos and I, along with some, Aaron Anderson and other students, have been running infants on this. I'm going to leave it at that.
All right. And then the question I had is, there's some so this is what exactly you mean, or where do you place the difficulty in acquiring these words, and whether it's at the perceptual conceptual level or at the sort of variability in how the word is used? Because there's some linguistic analysis suggesting that something like in may be a primitive concept, and also all the developmental work that might suggest that children really understand things like behind very early, with all the, the solidity constraints of things cannot passing through one another, and on that comes in not immediately, but maybe early-ish. And so I wonder if it's, these are primitive concepts and they're just working memory constraints or executive function constraints. And these things are perfectly perceivable and codable, or maybe it's the words that are used in a way that doesn't map accurately.
Yeah, that's it. Okay, good question. And certainly I will say that there's a very strong, contingent of smart people who would argue that we basically come with innate correlations, of which same and different, for example, Susan Gary, and same and different would be among them. I'm taking a different stance. And of course, if we'll see, I could well be wrong, but my comment on the baby stuff is, first of all, it's not so easy. There are lots of cases where a kid can do one kind of on, but not another. And they could do on with these two objects, but not with those two objects, and so on. And people like Marianella Casasola find that the same things can influence babies that I would find in older kids. So comparing examples of on or in will lead to better performance. Using the word while showing the examples will lead to better performance, and so on. So I'm not so sure that we have to take this as evidence of innateness yet.
It would be a bit ironic if the innate concepts always corresponded to the words of English.
Yes.
It is an interesting fact, but of course that's because it's God's language. We know that.
Can I say something? So, firstly, it's amazing to hear that presentation. I found it really fascinating. And yeah, and Dedre, we haven't met, but I've read so much of your work, so it's like a very, very amazing to be able to.
I'm flattered.
to interact, but just on the thing that Idan said, is it possible that there could easily be animals that whose environment has it such that the identification of something like a quality of predators or anything else is particularly adaptive, but that is just one very specific relation that they are able to do, and that feels to me like fundamentally different from learning to deal with relations in a more general sense. So could that possibly explain some of the observations with animals that people have raised?
Well, I think that's a great point. And I've heard it argued, for example, that squirrels come evolutionarily ready to do detours in a way that dogs don't, for example. And dogs are pretty smart. I don't know if this still holds up. I'm not a, ecologist, but, and the answer is that, yes, of course, it could be that, that chimpanzees just come ready for same. My argument about chimpanzees, and the reason I wanted to present those data is, they don't do it without the symbols. It isn't something that, oops, that just happens to chimpanzees no matter what. So the fact that you don't see this in just any old chimp makes me think that special experience of some kind or another actually allows a general purpose learning system in chimps that we have, of which we have a similar mechanism, though ours is, we're just incredibly good relational learners. There's lots of evidence for that. And some people have argued that, for example, Holyoke has argued that we are the only animal that has advanced relational learning or any relational learning, and chimpanzees are just sort of shuffling through on other grounds. I think that's wrong. I think it's very clear evidence that they can pass some relational tests, including others I didn't talk about. But it's absolutely right that we're just paragons, which I think, by the way, is why we get to rule the earth, for better or worse. Anyway.
Thank you, Dedre. All right.